For my Make a Splash video, I am doing my video on cone snails. In this video, we will be learning the basic information on cone snails. How will scientists aquaculture cone snails? Why should scientists aquaculture them? And the benefits that we can get from the cone snail venom. Basic information on cone snails. Cone snails are invertebrates, which means they don't have backbones. They are carnivores. They eat fish, worms, and other snails. They grow between 1 to 9 inches. They live in tropical waters like the Caribbean, Red Sea, Indian, and Pacific Oceans. They live in depths between 0 meters to 200 meters. Aquaculture versus wild harvest. There are both pros and cons for each. Pros for aquaculture is the supply is there. Researchers can research them more, and researchers and scientists can keep them for a long time. The cons for aquaculture is there's a limited amount of times you can harvest the venom. This means that the researchers and scientists will need to wait until the cone snails have another radial tooth to grow back, and they need to wait for the snails to grow if the snails are too small to harvest the venom. The wild harvest pros are there's more of them, which equals the supply. Also, they can put them back into the habitat. The cons for wild harvest is that the cone snails help the environment, and they would need to go out and retrieve the snails. The setup. So we would want at least a 5-gallon tank. Water, we would want to have 3 pH levels and a heater. The heater's for making sure the water temperature is good. We want an air pump and an air stone to get some air flowing through the water. Food, we would want worms and fish because that's mainly what cone snails eat. And other stuff, we would want substrate and some plants to make the tank more homey for the cone snail. How will we get the venom? So it's a exchange system. So the cone snail will give the researcher or scientist the venom, and in return the snail will get some food, like a goldfish. The National Institute of Standards and Technology says the cone snail has learned to exchange venom for dinner. Here, a snail extends its proboscis and discharges a shot of venom into a latex tube. In the pictures, you will see the cone snail shooting the venom into the tube, and in return is getting a goldfish for dinner. Why should we aquaculture cone snails? Cone snails' venom will provide us a new pharmaceutical medicine. It will provide people a new option for medicine. Also, cone snails' venom will provide a stepping stone in the future for medicine similar. Potential problems. Economically, this will cost money. It will cost money to manufacture and buy the cone snail's venom to make the medicine. You will also need to market the medicine to other people, and to start aquaculture in species, it costs money. Socially, it is limited to people who are economically stable or have good insurance. It is also not well known to people that there is a non-addictive pain medicine made from cone snail venom. Why would it be beneficial? The medicine that can be used from the venom is a conotide. The brand name of this is Pryout. This is a non-addictive pain medicine for people. It changes the type of medicine doctors use in the medical field, trying to steer away from the non-opioid medicines and gives an option to people. It also provides a research purpose of trying to figure out other non-addictive medicines for people. In the paper, Pain Therapeutics from Cone Snail Venoms, from Zikinotide to Novel Non-T-Opioid Pathways, the paper gives a general overview on zikinotide. It talks about how the opioids are good for acute short-term pain, but there is still problems that arise from them, like a lack of long-term efficiency, opioid-related side effects that are common and may prohibit further doses. Opioids can cause an unfortunate dependence after prolonged use, which can result in a withdrawal experience or a tendency towards addiction. The paper says the current opioid epidemic is the deadliest drug crisis in American history. Thus, this review on the discovery of non-opioid pain therapeutics and pathways from cone snail venoms is significantly in timing. Then the paper talks about zikinotide, which was approved by the FDA in 2004. It has become a non-opioid pain medicine. Clinically, zikinotide is often used as a last resort due to the relatively high cost and the requirement of an intracatheter pump, but recent guidelines encourage the use of zikinotide as a first-line agent in various pain conditions, including neuropathic pain. The paper says clinical trials of intracatheterly administered zikinotide have demonstrated good efficacy in both chronic and cancer-related pains. Other papers you can look at online for free if you're still interested in this topic. So in this video, we learned the basic information on cone snails, how will scientists aquaculture them, the potential downsides from aquaculturing cone snails, the medicine that comes from the venom of cone snails, and why we need this medicine. Here are my research and picture citations.